positive real numbers means that this puts us in quadrant 1. So when our graphs turn to applications, in the real world, we can't take any negative lengths, any negative amounts, and negative time. So that's why we're constantly in quadrant 1. Okay, this probably will be okay. Everybody has this in front of them, right? So this is where your let statement comes in. This is the first positive real number. Because these are applications, you need to use let statements. This is the second positive real number. Okay, now, we said whenever we maximize or minimize, whenever you see the word maximize or minimize, this is the key where it goes into your y1 equals, whatever we're going to do here. So if we want to maximize our area formula is going to go into your calculator, y equals the area of whatever we're doing. If we're going to minimize, that means probably it's the perimeter or the sum that's going to go into your y1 of whatever we're doing. So that's key to start out there. We also remember that a maximize gives us this. We get a maximum value. A minimize gives us this. We get a minimum value. Those are the things we're looking at. Okay? So we're going to start out with this. The product is a maximum. This is going to go in my y1. So I say, in my y1, I'm going to put x times y. But I say, whoops, I can't put times y. I can only have one variable in there. So I have to have some kind of information that will help me substitute this guy out of there. So I look back and they said, oh, the sum of these two numbers is 110. So I take the sum of these numbers. Now, can I solve for y in terms of x? Can I get y by itself in this equation? Yep. How would I get y by itself? Minus x. We say that that's your transformation. Solve for y in terms of x. So you want to make it say y equals, and you want to make x be on the other side. So now I can substitute this piece into here. And I get this. Oops. My board just went buckle. And I get this. Now, I want you to think about this for a second. Just for a second. When we say this, these are two factors, right? So picture just distributing these out. I get 110x minus x squared, right? There's my parabola. Where does it turn? Up or down? Down, because a is -1, right? Oh, so don't I want a maximum? Aren't I turning my parabola down so I can get a maximum? It fits right into this piece right here. It's giving me a maximum, and this will be my absolute maximum that I need to find. When I find it, this guy represents my product in my y1. So when I get a value of x and y, I'm technically getting x and y1. This is my number. This is my product. So I take this and I put this in my calculator. Now the problem is I need to adjust my windows because this is higher than my 1 through 10. Now, just before you put it in your calculator, look up here for 1 second. If you can make sense out of these things, it's far, far easier. You have a number of ways to do this. This right here, when we set this equal to 0, don't we normally factor this? When we set this equal to 0, don't we normally factor it and find out where your zeros, your x intercepts? So that doesn't that tell us where x goes from to the end? So if we're already here, can we kind of set these equal to 0? So x is going to start at 0 and x is going to end at 110. So my domain could possibly go from 0 to 110. If I think about it logically. If I think about it logically, two numbers, even if I say 110, I still need to go to x is 100, don't I? Or 109 and 1. I still need to go to 109 and 1. and then I need to take your product. That would be my small product. What gave us the biggest product when we looked at a rectangle? What gave us the maximum product, the maximum area? And the numbers on the rectangles were where? Far apart or close together? Close together. So even if I estimate 50 times 50, what is 50 times 50? 2,500. Even if I make my y max be 2,500, I may have to make it a little bit bigger because half of 110 is obviously 55. I'm just estimating. But do you see what I'm saying here? Estimate this. Make sense out of your problems. That's why we do these. We like to make sense out of these. If you make sense out of them, they're going to be so much easier than trying to figure out what to do with them. Okay, let me pull up my calculator. We're going to put this in your calculator. So you get it in there and try to adjust your window. That's 90% of the problem is adjusting the window. We talked about a few different ways to look at this. We can also put it in, we can also go to our table and say, well, a maximum graph, your y is increasing, reaches a point, and decreases. We can look for that turning point. 110 is not that bad. If we have to, we can certainly find 110. So I'm going to come to here. Oh, I already have it in. And I'm going to say, okay, maybe my maximum was 100. I'm just putting numbers in. Maybe my maximum was 100. And maybe my maximum value was 2,500. If I thought this and I graphed it, I say, whoops, I missed the height. I missed the end of the x. So what am I going to have to change? My y max is going to have to go up a lot. And what's going to happen to my x max? I got to make it longer, right? I got to see where it hits the ground. So, okay, go to your y max, go to your x max, make it 150. Normally I like to say double, but we don't need to go that far because we were pretty far. Go to your y max, make it 35. I'm going to make it 35. Does it matter? Like my window? Gave 132. Did you also get a parabola? And you saw the top? So that's fine. My goal is to get something so that now I can say, find me my maximum value. Second, calc, maximum, go to the left of it, go to the right of it. I want to find my maximum. Let your calculator find it. And guess. There's my maximum. And ignore the 0.006. Your calculator does weird things with these sometimes. So 55, 3,025. So what'd you get? Don't trace. Don't do trace.
No, I went to max.
You went to max?
Yeah, and I got like 50.
Okay, you probably missed the turn. Try it again. Go far enough to the left and far enough to the right. Sometimes what happens with the calculator, it makes the top look flat.
Yeah.
So you've got to get past the bump. So go well enough to the left, well enough to the right.
So wait, how did you get that? Like, I'm not understanding how you got the things to change your window. That's what I'm not understanding.
Okay, so let me go to a zoom 6. Let's start this. I'm going to do a zoom 6, right? I see nothing. I say, how come I can't see anything? I'm supposed to see a parabola. What's my parabola supposed to look like? Up and down. Yeah, but I don't see it. So let me go to my table. And let me start my table at 0. I want to see what's going on here. Start my table at 0. And I notice, wow, look how high these numbers are. As you see? See these numbers increasing?
Yeah.
So follow your y values. You want to see if you could spot where it turns. I'm no longer 0 to 10 anymore. So I'm scrolling down. I'm just going to keep scrolling down. It's not that bad, and I'll show you another way in a second to look at it again. But I'm scrolling down. I still see it increasing. Are my y's still increasing? See my y's increasing still?
Yeah.
I want to catch when they decrease. Now, I noticed, it started to decrease. There's my actual turning point. Do I have to be exact? No. But I say, oh, okay, I stopped at 57. I'm on the decreasing side. So I'm going to take this, I'm halfway through. Double that x. So round it. If it's 60, double it to 120. You need to see the rest of the parabola. This would be my maximum height, somewhere in that little area. So go a little higher. Make it 3,500. Make it 4,000. You need a big enough window to be able to see it. So let's say, okay, I want to make this, I got to start them at the zeros because I'm in the positive numbers. I want to go 120. I want to start this at the 0 again. And what did we say? Let's go 4,000. I'm somewhere around there. Oops, I got to change that. My thing does crazy things here. Okay. Let me graph. Can I see my graph turn so that now I can do a max on it? Absolutely. Now, another way to do this, guys, it's popping up, I don't know why, is this. Just watch up here for a second. When you're looking at your table, okay, I'm just going to start it back at the 0. I look at my table and I say, oh wow, I'm increasing. How long am I going to have to do this for? So I really don't want to sit here with my finger on the button. If I have two numbers that add up to 110, I can't obviously go higher than 100, right? My x is not going to go higher than 110, no doubt, 109. So if you go to table set and you start at 0, see the delta table? That means instead of going by ones, maybe I want to go by tens. You watching? So now watch. Now I can see myself increasing. I'm increasing. Oh, I'm the same here. And then what's going to happen to my y's? They're going to start decreasing. So I say, somewhere in here, I turn. Isn't that easier? You're looking at less values. I don't want an exact value. So I'll take 60, I'll double it, give me 120, and I'll take 3,000, that's my max right now. I'll go a little more, make it 4,000. All I need is a window to see it. So your delta on your table set is nice. If my numbers added up to 500, what would be a good delta to make? Instead of 10, what could I go by? If I have to look for numbers that go from 0 to 500, and I want to do it quicker than scrolling down every single number, what could I change my delta? 50. I'm only looking at 10 numbers that way, aren't I? 10 times 50, I'm only looking at 10 sets of numbers. Your turning point, you do not have to find it in your table. You just have to find the spot that is approximate so that you can see it in your graph. And don't panic about changing your windows wrong, because if you change your windows wrong, go back to Zoom 6 and start again. Like if it gets that bad looking, just say Zoom 6, get your zeros back to your minimums, and you start again. So that's how we solve these problems. Okay, now, watch up here for 1 second. Algebraically, here's my graph. Oh, I'm sorry, we didn't finish this exactly. This was my x value. This is my y1. This represents my product. Now, take this back here. X is my first variable, my first positive number. My second one is this, y. So I bring this 55 back into here, and I say y equals 110 minus 55. Oh, that's also 55. Now, I said yesterday you're going to see some kind of pattern, which is why I wanted to do the rectangle first. If we're maximizing area, we found that it works better when the numbers are either the same or close as possible to being the same, right? That's what's going to maximize your area and minimize your perimeter. Area is product, perimeter is sum. So that makes sense. Now, if we solve this algebraically, watch. I'm going to turn this around. Now I'm going to complete the square, because we know how to find your vertex on this, which would be my maximum point, wouldn't it? if I find my vertex. So I'm going to factor out the -1 plus something. And I have nothing else here, but since I added, I have to subtract something. So what's half of -110? 55. And what's 55 squared? 3,025. And bring it out of here by subtracting. Take the opposite. If I take the opposite, I'm adding it. There's my negative for my parabola turning down, and there's my vertex. So didn't we do these algebraically first? And now we're doing them graphically. Yes?
So,
No.
so,
Okay. Now, again, it's the same let statement. I have two positive real numbers. I'll never catch this board ever, for some reason. Oops, that's too small. All right. The product is a minimum. So you have, oh my goodness. It's like my board is haunted. Mm. Okay, my product and my sum is at a minimum here. This is what you have for number 2, right?
yeah.
All right, so we're going to start like this. I'm going to let x equal my first real number. I'm going to let y, positive real number, equal my second positive real number. Okay? Now, this time, remember we look for the word maximum and minimum. Do you see it in the sentence? Right here. What is a minimum? Sum. So, in my calculator, y1 is going to be my sum of whatever it is that I have to do. So I have two numbers. How do I get the sum of two numbers? Add them. So my y1 says x plus y. We said this is a minimum, so my graph should look like this somehow. And down here, at my vertex, should be my minimum point. That's my goal, to get there. So I say, okay, you got to give me some more information, because I can't use x plus y in my y1. So, oh, I have another piece of information. My product of these two numbers is 192. So how do I say that? What math sentence do I use? Equals x times y. Now, I need to solve for y in terms of x. I needed to say y equals. Divide, good, divide by x. This is what I'm going to substitute in for this guy. So you're going to substitute this in, and you're going to get this. So I take out that y. Okay, now, I'm going to go to graph this. Let's think this out a second. I have two numbers whose product is 192. Well, as a matter of fact, let's find it on our graph. Let's find it on the graph. That'll be a little bit more challenging. So we're going to go to your y equals. We're going to take this guy out, and we're going to put in, just like you read it, don't reduce anything, don't distribute anything. Let your calculator worry about it, because that's not our goal, is that equation. Okay, now, maybe I can use the same graph as we just used. Let me try. Not really liking this. What was my window before? My window is kind of high on my y, kind of high on my x max. So let me think this out. Let me go look at my table here. My tables go by tens. Let me start it at 0, and let me go by tens. Let me see what I got going on. My y value It's a minimum. So I should be decreasing, decreasing, turn, increase, increase, right? So am I decreasing, decreasing? Oops, I'm not decreasing, right?
Wait, where?
I should be decreasing, decreasing, turning to increase. So am I getting that? No. So let's just break this down. Let's go start back at 0. Let me make sure I put it in the right way too. Maybe yours is. Not mine's good.
Yeah, where?
Oh, yeah, you got decimals.
I got
But am I decreasing? Oh, well, you might just have to change your, just go to math. Go to math and hit enter. Or hit enter on the decimal. Go to math, come down into the decimal, and hit enter on your decimal. Does it go to decimals now?
Oh, I got this.
No? It should. But you should be able to catch that. Is this decreasing now? Means it's decreasing soon, right? I didn't have to double anything. Am I ever increasing yet? Am I still decreasing? Keep an eye on your Y. Oh, did I still keep decreasing? Nope, somewhere in here, I was decreasing. Oh, and I started to increase. But I don't care where exactly. I just know it's over here somewhere. So let me take 16. Let me double 16. I get 30. I'll make my window 40. This is your Y minimum. I need to see my Y minimum, but I don't want to see it at the top of my screen. So we said, okay, make your X max 40. And let's make my Y max, can't be 4,000 because we were pretty low there. Let me make it 100. I need to see my graph turn. Now, you notice with these guys, they're not exactly parabolas because they're irrational. They're rational problems. My window was 40 on the X max, 100 on the Y max. Now, remember with your rationals, your denominator can't be 0 because the X was down there. So it made you 2 places. We don't care what's in quadrant 3. We only care what's in quadrant 1. Now watch, I want to show you something. If it's hard for you to locate your minimum here, change your X value and make it a little higher. So say if I go to 60, it's going to make this curve a little bit sharper. So now is my minimum a little easier to find? So my minimum says second calc, give me a minimum. Go to the left of that bump, make sure you go to the left of it. Okay, go to the right of it. And see what your minimum is. So my minimum comes out to be, and when I have all those decimals, what do I round to? 3 decimals. 13.856, and my product is what I found here. My sum is what I'm finding in my Y1. So 27.713. This is my sum. My product was over here. This is my sum. This is my X value. So I know what my X is. I come back here, plug this in here. I do 192 divided by 13.856. And what do I get? What do I get for my Y? No, 192 divided by 13.856. 13.856 again. God bless you. Right? So is it my perimeter, my sum at a minimum? God bless you. When my pieces are about the same. Right? Are we kind of seeing a pattern? All right. Now, a number of ways to do that too is, don't forget, make sense out of your numbers. If you have 2 numbers that give you a product of 192, even like 10 times 10, is 1,000. That's way too high, right? 10 times 10 is 100. If we did 10 times 10, 100, I'm close. If I did 20 times 20, what would my product be? What's 20 times 20? 400. I'm a little too high on that. So I know it's not going to be 20 times 20. Remember, we said that they're about the same. When we're maximizing area, minimizing perimeters, they're the same. So 20 times 20 is way too high for me. Now, normally you'll see your minimum. What happens if your Y value is too high? You're going to see your minimum barely up here. Barely up there. Your Y is too high. Because even though we're looking at your Y max when we're looking there, your minimum is down here. So keep an eye on where your minimum goes. Let's walk this through. The product, again, the directions for 1 through 4 was I have two positive integers, two positive real numbers. So let x equal your first positive real number, and let y equal your second positive real number. Okay. Now, what am I maximizing or minimizing? Look for the word maximize or minimize. Minimum. So what am I doing a minimum on? The sum is a minimum. Just don't worry about all those pieces in there. Just the sum is a minimum. This is what goes into my y1. So start like this. Sum. Well, that's what's going to help us get your x and your y. But my sum is at a minimum. My product is at something else right now. My product is at 192. But let's see what this is. So your product is at 192. How do I say that as a math statement? X times y. Now, the sum of the first plus 3 times the second is at a minimum. That's what my sum is going to be. This is what my sum has to be. How do I write that? X plus 3y. Perfect. 3 times the first. Oops, sorry. The first plus 3 times the second. Which guy was your second according to your left statement? Y. Your first was your x. This is what's going to go into your y1. Now you're a minimum. What should your parabola look like? Open up or open down? Minimum, open up. You want a minimum point. Okay? We're pretty good here because we probably can use your other graph because your product is still 192, right? The numbers are going to change because we changed the way we set up your sum. But we're still within that time frame. Now, we need to substitute out for y. So we come here to the only other statement they give us, and we solve for y in terms of x. So we divide both sides by x, same as we did in the last one, and we bring it back over here. Just be careful that you keep parentheses around this guy. Now, my y1 is giving me a sum. When I get my answer back for my minimum, my vertex point, this is going to be my first number. This y is going to be my sum. See if you can find it. Work with your calculator. We put it in your calc. Did we try using the same window that we just had before? That's pretty good. If you struggle with seeing your minimum, make your x max go a little bit higher. Watch what happens. If I make my x max go a little bit higher, it makes that slope a little steeper. Is that easier to find the minimum then? If it helps you? So find your minimum. Again, use your tick marks. Go to the left, go to the right. If you can set it using x values, that's fine. It's usually a little harder to tell once you change your window. I find this just to be easier. You don't even have to stop and think about what your x values are. Go to the right. And do your minimum. Now again, your calculator rounds a little bit weird in here, but your minimum is at 24, 48 point something. What was the 48? Okay. 2448. This is your x. This is your y1. This is your sum. Bring this x back to here to find your y. So y would be 8. Your x is 24. Your y is equal to 8. Good? Question?